All right, moving right along. We left off on number 25. In problem number 25, I had transformed, put this into standard form. I've noticed that the factors 2 and 8, that 32 had factors 2 and 8, so I thought it would be easy to find intercepts, so that's what I'm working on right now. I'd plugged in x for 0, 2 times 0, gave me 8y is 32, found 4. Now I'm plugging in 0 for y. 8 times 0 is going to give me 0, 2 times 16. Well, I tried this. Come to find out, x-intercept, let's see, 0, 4, 0, 4. There's my y-intercept, and my x-intercept is off the page. But you know what I do have right now is two pairs, x and y, 0, 4, and 16, 0, and I can do a quick slope calculation now that I have the y-intercept. The difference in the y value is 4 minus 0 in the numerator. The difference in the x value is 0 minus 16 in the denominator. 4 over negative 16 is going to reduce to negative 1/4. So from here I can go down 1 to the right 4 and draw my line. And again, since I don't know anything about the context of this problem, I'll assume that all the values along that line make sense. Moving on, I'm going to write some equations. Number 26, let's see what it lends itself to. I have a slope and a y-intercept. Y equals mx plus b. Easy money. Number 27, I have a point and a slope. So I'm going to use point-slope form. Y minus y sub 1. So y minus negative 2 is going to be y plus 2 equals m times x minus x sub 1. I'm going to actually distribute and simplify this down to y equals mx plus b. Negative 1x plus 4. I'm going to subtract 2 from both sides. Y is equal to negative x plus 2. I like doing it that way so then I can see it actually has a y-intercept of 2 as well. Although we could have plotted it before. This answer was point slope. Number 28, I'm going to use point slope form again, but the first thing I'm going to have to do is calculate the slope. Let's see, do I notice anything? 0. Oh no, I have the y-intercept right here. Perfect. Here's my b value. So I'm going to start by calculating the slope. Difference in y is 2 minus negative 1. It's going to give me 2 plus 1. And negative 3 minus 0. It's going to give me 3 over negative 3. My slope is negative 1. I noticed that my b was negative 1. So y equals negative x minus 1. There's your slope, negative 1x. I have another situation here where I'm recognizing that there's the b. I'm going to switch colors. The green's starting to run together for me. I'm recognizing that the b is 4, so y equals mx plus b is going to be the route to go again. Let me calculate the slope quickly. 4 minus negative 1 is going to give me 4 plus 1. And 0 minus negative 1 is going to give me 0 plus 1. So my slope is 5. Y equals 5x plus 4. I have number 30. I have to write an equation that goes through the point 2, 0 that's parallel to 2/3 x. If it's parallel, that means it has the same slope. So I'm going to use point slope form. I have one point and the slope. This is the x-intercept, but I don't have any use for that in terms of writing an equation. There's no quick way to get there. This is going to be y minus y sub 1. Well, since it's y sub 1 is 0, I'm just going to write y minus nothing. I'm not going to write y minus anything. Equals the slope times the quantity x minus x1. So I can distribute this as well, and actually it lends itself pretty quickly to slope-intercept form. I'll see what that y-intercept is here. When I multiply 2/3 by 2, that would give me minus 4/3. I don't want to have to graph that, but there we go. This would work too. Perpendicular to in number 31. If lines are perpendicular to each other, their slopes are opposite reciprocals. So the slope here is negative 2/7. So the opposite reciprocal is positive 7/2. It goes through this point. Y minus 4 equals 7/2 times x minus 2. I'm going to leave it there. We're not going to simplify that down to y equals mx plus b. I want to try to finish this up. Number 32. We have to solve a problem and write an equation to solve it. You receive $100 for a graduation present and put it into a savings account. Each week after, you add $5, but no interest is earned. This is a linear situation. Weeks I'm going to use for my first unknown and how it relates to time passing. So this is just going to be my total amount. Weeks is W, total amount is T. When would you have $310? 100 plus 5W. When's it equal to 310? 5W equals 210 if I take 100 away from both sides. And if I divide 210 by 5, it would take 42 weeks to make that happen. 42 weeks. Marty's spending money at the average rate of $3 a day. After 14 days, he has $68 left. Write an equation that shows the amount of money he has left as it relates to the number of days passing. He started with 68. He's spending 3 per day. And after, oh, I've got it. 14 days, he had 68 left. I think I went at this the wrong way. No, I totally went at this the wrong way. He is spending $3 per day. He had 68 left. How much did he start with? There we go. Yeah, that's what I want to know. Start minus 3 times 14 gave him 68. 14 days, he had $68 left. So however much he started with, minus 3 times 14. So what I'm finding is that that worked out to be start minus $42 was 68. If I add 42 back to what I had, I find out that he started with $110. I was on the right track with this equation, but I wanted to get an answer, so I went for it. Excuse me. Biologists have found the number of cricket chirps that crickets make per minute. It's related to temperature. It's linear. We have two pieces of information here. We have cricket chirps in minutes and the temperature out. When they chirp 172 times, we have another temperature. I believe that we've discussed this in class, that temperature is going to be our X value and chirps is going to be our Y. And what we know then is at 68, there's 124 chirps, and at 80 degrees, there's 172 chirps. Wants to know what the temperature is if the crickets are chirping 150 times a minute. Well, I need to get myself to an equation in order to solve this problem. The rate of change is 172 minus 124 over 80 minus 68. 172 minus 124 is going to give me 48 over 28, I believe. Oh, no, that's not 28, that's 12. So the crickets are chirping at a rate of, let's talk about this. Oh, we need a y-intercept. What do they start with? Crickets are chirping at a rate of, I believe, 4 chirps per minute, but we've got to go back and find out the starting value, or the b, where this equation and this situation starts. I'm going to actually solve for b by using the slope in this point x and y. 172 y equals 4 times this x plus the unknown start. 4 times 80 is going to give me 320. And when I take 172 minus 320, well, this is an interesting one. So this is 320 plus b. When I took away 320, I found that b is negative 148. This is an example of a problem we have that the y-intercept doesn't make sense in the problem. So the number of chirps, c, is equal to 4 times the temperature in degrees minus 148. Now this question says, what's the temperature if the crickets are chirping 150 times a minute? We plug in 150. When we add 150 to both sides, we get 298 equals 4t. Our estimate for, oh, hitting my calculator here, about 74.5 degrees.